Gosh, Pocket Ronnie made me enjoy eating triangles. So welcome back.
Okay, we're doing composite functions today. What that means is we're taking functions, and we're going to be adding them, subtracting them, multiplying, dividing them, and substituting them in to each other. Okay, so looking at the test page under test 20, problem number 3, you're given this function, f of x equals x squared. Remember, f of x, that's just another fancy way to say y, equals x squared. That's a parabola. And g of x equals negative x plus 1. That'd be a line. It doesn't matter what they look like on a graph, but I'm just letting you know. So the problem asks, what is f of x plus 2 times g of x? That's what this means, 2 times g of x. So basically we take f of x, which we said f of x was x squared, plus 2 times, and g of x is negative x plus 1. Now we're just simplifying that. So I have to distribute the 2. So that'll be x squared plus, that'd be at negative 2x plus 2. I can't combine x squares to x's to whole numbers, and so that would be your final answer for that one. Okay, now looking at number 7 on test 20. Here we are subtracting functions. You have to be very careful of watching for distributing negative signs in this. Okay, the problem says they want you to factor r of p minus z of p. So we're going to take the function r of p, subtract z of p. So r of p is p squared plus 1. So I'm taking my p squared plus 1, which is r of p, and I'm going to subtract. So that subtraction sign there is that subtraction sign there. Now z of p, this whole function. Whenever you have a subtraction sign, it's always good to put parentheses and then write your next function, because this subtraction sign now needs to be distributed. So when you're subtracting more than one term, you need to put this in parentheses and then distribute this negative. So this would become p squared plus 1 plus 3p plus 1. Combine like terms, we can combine my whole numbers, be p squared plus, and I'm going to put it in order of p squared p, and then combine my 1's plus 2. The original problem said they want you to factor this. They want you to do r of p minus z of p, then factor. So now that I've got this trinomial, now I need to factor it. I can't factor anything out. I'm in a positive world. Only factors of 2 are 2 and 1. And so if you FOIL that back out, you will end up getting that trinomial. Okay, now looking at 20A, number 12. Now we are multiplying two functions. Watch your operation sign. So this is multiplying two functions. I'm taking f of x, multiplying it to g of x. So f of x, I'm told right here, is x plus 3. So x plus 3 times g of x is x squared plus 3. So I'm multiplying these two parentheses together. I'm just FOILing it out, okay? Taking this and distributing it to both things. So I would have x cubed plus 3x. Now take this and distribute it to both things. Plus 3x squared plus 9. Okay, is there anything I can combine together? No, I can't combine x cubes to x squares or x's to whole numbers. There is nothing that is the same kind. But I am going to rewrite it to where my exponents are counting down to where I have my x cubed, then my x squared term, then my x term, then my whole numbers. That will be your final answer. Okay, now moving down to 20D on number 12. Here we are dividing functions. You're doing f of x divided by g of x. So f of x, we are told, is x squared divided by g of x, or x squared plus x, divided by g of x, which is just x. Sometimes you won't be able to simplify these any more than what you have there, but sometimes you can. So you need to look. We're not going to do long division for any of these, but look to see if you can simplify. The main thing you're looking to see is, can you factor something out of the numerator, okay? You can only cancel when things are multiplied. So here, I can factor an x out of the numerator. So if I factor an x out of the numerator, I end up with this, because that distributing back would give me x squared plus x all over x. And so these x's are multiplied, so they can be canceled, and you're just left with x plus 1. Okay, now we're looking at, on test 20, number 2, we're going to be doing this, the way you say this is f of g of x. We're doing a function of a function. Okay, our f of x equals x squared, g of x equals negative x plus 1. The best way that I can tell you for these is to start from the inside and work your way out. Okay, so the way this is read is f of g of x. So what this means is you're going to take g of x and put it into f. So you're taking what's in here and you're taking this and putting it into f. In other words, you are taking g of x and you're putting it into f of x. So when you do that, you're basically saying, okay, I'm going to put g of x in for right here, which gives you that, puts you that. And so what this means is everywhere you're putting in an x, you're putting in whatever this is. So if you're writing this, you say f of g of x. Well, g of x is, you can say f of negative x plus 1 equals, g of x is negative x plus 1. Whatever you put here, you're saying, I'm going to take whatever I put here and substitute it everywhere I see an x. So in other words, here's my function, so everywhere I see an x, I'm substituting in this. So everywhere I see an x, this basically gets substituted in for x everywhere. So everywhere you see an x, you are substituting in this. So I'm now putting this, I put that in for x, but I have to raise it to the second power. So f of g of x equals negative x plus 1 times negative x plus 1. Now multiplying that out, that would be a positive x squared, negative 1x, negative 1x, and then a positive 1. Combining like terms, that would be negative 2x plus 1, and this is what f of g of x would be. Again, we took g of x, we took this, and substituted in for f of x. We put it in for x. Everywhere you see an x, you basically substitute this in. Alright, now it's looking at, on test 20, number 4, we're still doing a function of a function. Here, f of x is x squared, g of x is negative x plus 1. Now you're doing g of f of 3. So you are still substituting, you're taking f of x and putting it in for g, but before you do that, you're doing f of 3. Okay? So what this means, f of 3, so here, do you notice we have a 3 instead of an x? So basically we're saying x equals 3. So everywhere we see an x in the f function, we're going to put in 3. Okay? So basically you're putting in 3 into f of x. That's the first thing that we're going to do. Okay? So we go to f of x. We said f of x equals x squared. Well, this tells us we're putting a 3 in for x. So f of 3, this means we substituted 3 in for x, which means we substitute 3 in for x over here as well. So f of 3 equals 9. Once you know that, then you take this whole thing and substitute it into the g of x. Okay? So we found out that f of 3 was 9, which we can basically replace. Up here, we can replace my f of 3 with a 9 and call it g of 9. Okay, so what we're saying is now we want to put 9 into the g of x function. Everywhere we're substituting in 9 for x. Okay, so remember our g of x function is negative x plus 1, but we are doing 9. We're taking 9 now, because that was f of 3, and substituting in for g of x. So we're taking 9, which is right here, and we're putting it in for x. Well, if you put it in for x right there, you also have to put it in for x right there. Everywhere you see an x, you're substituting in 9 plus 1. So basically, turns out that g of f of 3, which was the original problem, was equal to -8. So basically, we're just taking 3 and substituting in for x in the f function. Then we take that answer and substitute it in for x in the g function.